Question 3.3. So what is this question saying? Obtain equations of motion for constant acceleration using method of calculus. Equations of motion. What are the equations of motion? We know the equations of motion are V equal to U plus AT, S is equal to UT plus half AT square, V square equal to U square plus 2AS. V is final velocity, U is initial velocity, A is acceleration, S is distance, T is time. So this is what we are supposed to solve using the method of calculus, using equations of using calculus. So let's start. So what do we know by definition? By definition we know A is equal to dV by dt, right? dV by dt. Acceleration is equal to rate of change of velocity. So now how do you do this? Now just cross multiply. So we get A dt is equal to dV. Now let's take integration. Now this is respect to t, the integration. So this will be from t naught to t. Here the integration will be v naught to v. So what do we get here? We get A, that's a constant that will come outside. Integration of dt is t from t naught to t, which is equal to integration of dv, that is v, initial velocity, final velocity. Now this will be final minus initial. We get t minus t naught, t minus t naught is equal to v minus v naught. So when we simplify this, what do we get? We get v equal to, so what is t naught here? T naught is 0, initial velocity, initial time. If the initial time is 0, what do we get? V equal to v naught plus at. This is equal to v equal to u plus at, first equation of motion. Now let's get the second equation of motion. Let's solve for the second equation of motion. How do you find the second equation of motion? Let's use the formula v equal to dx by dt. Cross multiply, we get v dt equal to dx. Integrate this. What do we get? But can we replace v? Shall we replace v? We can replace it by v naught plus at is equal to integration of dx. This is our first equation of motion. Now this dt here, so this is in terms of t, so this will be from 0 to t, initial time is 0, dx will be from x naught to x. So what will we get here? Let's solve this, right? So we get v naught into, so this one v naught is a constant, we get t here plus a will come out, t will be t square by 2. So the entire thing is from 0 to t. Here we get x from x naught to x. So when we solve this, what do we get? We get v naught t plus at square by 2 minus 0, because t will be, when you put the initial time 0, this will be 0, this will be 0. This is equal to x minus x naught. So once we rearrange, we get x is equal to x naught plus v naught t plus half at square. This is the second equation of motion, that is x equal to ut plus half at square. The final equation, x equal to ut plus half at square. Here x naught is the initial distance. Now let's solve the third part of the equation. Third part of the equation of motion. So now let's solve the third part of the question. So we know A is equal to dv by dt. How can we write this? We can also write this as dv by dx into dx by dt. Would we get the same this thing? Right? We get the same this thing, dv by dt. So but what is dx by dt here? This is velocity. So we get v dv by dx. We get A is equal to v dv by dx. Now let's cross multiply here. What do we get? We get A dx equal to v dv. Let's integrate this. Dx from x naught to x, v from v naught to v. What do we get? We get A is a constant comes out, dx is integrated to be x, x naught to x is equal to v square by 2. This v it will be integrated as a n plus 1 by n plus 1, v2, v naught. So once you open this, what do we get? A into x minus x naught is equal to half v square minus v naught square. So what do we get here? Rearrange it. What do we get? We get v square. Cross multiply this 2 here. So we get v square equal to v naught square plus 2a x minus x naught. This is the final equation of motion. This is equal to v square equal to u square plus 2as. So this is the final equation. So this question is also solved. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. So we have a building here and a ball has been thrown from the top of the building. Okay, the ball is going in this direction. Okay, so this is the ball here. So this has been thrown with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. So it says from the ground to the point where the ball is thrown. From where was the ball thrown? This point. So this height here h is equal to 25 meters. Let's put small h here. It's 25 meters. How high will the ball rise? So there's a turning point here, right? Turning point before it is coming down. The ball is coming down. So what is the height here? What is the height from here? How high will the ball rise? So we need to find h dash here. What is h dash? How high will the ball rise? So what is this height here? A question mark. Now B part of the question is, how long will it take before the ball hits the ground? So what is the time taken for the ball to travel from here to here? What is the total time taken? Okay, that is our question. So they've said take g equal to 10 meters per second square. So let's start to solve this question. So the first part, we need to calculate we need to find the first part of the question is to find how high will the ball rise, right? So first question is to find what is h dash. So we know this question, from this first part of this thing, we know the ball has been thrown from the multi-story building. So it has been thrown with a velocity of 20 meter per second. So we know that the initial velocity is 20 meter per second. And then what do we know? We know that acceleration is minus 10 meter per second square. Is acting the acceleration due to gravity, it is acting opposite. So that is minus 10 meter per second square. Now we've got V, we've got A, we don't know what T is. So what formula, what equation of motion will you use to find the distance h dash? For this we can use the formula V square equal to U square, that is V naught square, plus 2A. Now S is Y minus Y naught. What is Y here? Why is it Y? Because it's thrown in this direction. So this is mentioned as Y. If it was in the horizontal direction, it would be mentioned as X. Since it is in the vertical direction, it has been mentioned as Y minus Y naught. What is the final velocity? Once the ball reaches the highest point here, what is the velocity there? That would be 0. What is the initial velocity here? That is 20 square plus 2 into 10 y minus y naught. So once we solve this, what do we get? Sorry, here it will be negative because it is minus 2a, because it's the acceleration here is minus 10. So we get 400 is equal to 20 y minus y naught. Solving this, we get h dash is equal to, this distance here is equal to 20 meters. We get h dash to be 20 meters. So what is the total height? What will be the total height here? We know total height will be this height, how high the ball has risen from the distance from the ground. That will be h dash plus h. That will be 20 plus 25 meters. That will give you 45 meters to be the distance of the height. Now the part B of the question is to find out the time taken. Time taken to go from here to here. Time taken to go from here to here. So let's solve this in two parts. First, find time taken to go this distance. Then find the time distance to go to this distance. So, first part, we can use the formula V equal to V naught plus 80. So, when the ball started from the height from the ball to the highest position, so that is what we're calculating here. The initial velocity was, final velocity is 0 here. The initial velocity was 20 meter per second plus, what is acceleration here? Negative 10. We need to find the time here. What is time? So how do we get, by simplifying, we get t equal to 2 seconds. We call the first time to be 2 seconds. Now what about when the ball came down, right, from the height to this place here? So we know here the initial velocity is 0. Then we've got total distance s here, that we found to be h dash by h. We got it to be 45 meters. We know a is equal to minus 10. So we've got initial velocity to be 0. S is a distance of 45 meters. Acceleration is 10 meter per second square. So we have to use the formula y is equal to y naught plus v naught t plus half at square. This is basically s equal to ut plus half at square. So what is the y here? What is the initial distance here? That is, sorry, the final distance. Final distance is 0. What is the initial distance here? That is 45 plus initial velocity is 0 minus, because the ball is falling from this position, so initial velocity is 0, minus half into g is 10 minus 10, that is by the negative sign there, t square. Now let's solve this. So we get 45 equal to 5t square. Solving this, we get t equal to 3 seconds. So total time would be t plus 2 seconds plus 3 seconds. So total time taken would be 5 seconds. So part B of the question has been solved.